Okay, this section we're going to be talking about parent functions, and this slide right here shows you some of the parent functions that you have already studied. So this one right here on the left, this one right here is a line. We've done lines in the past. That's a horizontal line. It's constant. This one is a line. It's specifically called identity function just because its equation is y equals x. So it's your diagonal line that goes through the origin. This one right here, absolute value, we've done that one. We've done square root. We have done the parabola, x to the third. You've studied that one. The last two may be new ones, the reciprocal function. Here, 1 over x. We'll study that one a little bit more. And then the greatest integer function. That's this one right here. So it looks like it's a step function. So in each of those functions, we should be able to figure out what the domain and range is, whether it's an odd or even function. So remember, odd and even deals with symmetry. If it's an odd function, it's symmetric with the origin. If it's an even function, it's symmetric with the y-axis. We should be able to find their intercepts, whether the function's increasing and decreasing, that type of behavior, and of course, any kind of symmetry that it has. Okay, so out of the functions that we had there on the front, let's go ahead and answer these questions and decide which ones go where. Okay, I'm going to pull those out so we can just see them one more time. I'll kind of move them in and out as we answer the questions. So the first question says, which functions have a domain, the set of all real numbers? So that would be the constant function. The identity function. Absolute value. Quadratic. The square root function doesn't have a domain of all reals. The quadratic does. The cubic function does. The reciprocal function does not. And the greatest integer function does. Okay, and then the next question below it says, which functions are even? So remember, even functions have symmetry with the y-axis. So that would be the constant function. Let's get some room here. So we've got the constant function, the absolute value, the quadratic, and the, let's see, cubic function, no, reciprocal function, no, and greatest integer function. So I guess just those three. All right, let's see what our next question is. Okay, so the next one says, which functions are odd? So remember, the odd function has symmetry with the origin, so that would be the identity function. If it's symmetric with the origin, that means if you fold it over the x and the y-axis, it will fold onto itself. So identity function, cubic function, and the reciprocal function. And then which function has no intercepts? So let's see, that would be the reciprocal function. The constant function has a y-intercept, the identity has an x and a y, absolute value x and a y, square root has x and a y, quadratic x and the y because they all have an intercept at the origin. Same with the cubic. The reciprocal function does not. So this would only be the reciprocal function. So in your homework, you're going to be asked a few questions about these parent functions. So you just kind of need to look at those parent functions and then decide whatever questions they give you, just which functions fall into the category of what for answers for whatever the questions are. Okay, now we're going to talk about a function whose graph resembles a set of stair steps. Sometimes they call these a step function. The most famous of the step function is called the greatest integer function, which has these symbols around it. That means greatest integer function. So it's not really a brackets, it's just kind of a double bracket maybe. Anyway, when you see that, that means it's the greatest integer less than or equal to x. So over here on the right, we have the greatest integer function graphed. The domain is the set of all real numbers. The range is the set of all integers, because these points right here in between each of those are not, there aren't any y values there, so that's not part of our range. So it's just the integer values. The y-intercept is 0, 0, and x-intercept is, let's see, and the y-intercept and the x-intercepts are 0, 0, and the interval 0 to 1. The graph is a constant between each pair of consecutive integers, and the graph jumps vertically 1 unit at each integer value. So we can see that right here. Okay, so this says take the greatest integer function f of x and add 1 to it. So basically what we're going to do is we're going to take that graph and we are going to move it up 1. So remember, the greatest integer function started here. So let's go back so we can see that. Right here at the origin, it was a closed circle. So right here was a closed circle and then an open circle. So when we come over here to graph that, we're going to have it normally would be a closed circle here, open circle here. We're going to take that graph and we're going to shift it up 1. So closed circle here, open circle here, and then you just close circle, open circle, and you can graph as many as you need to. We'll go the other direction. So this is a closed circle, open circle at the origin, closed circle, open circle, closed circle, open circle, and so on. Okay, now we're going to evaluate the value of f of 2.6. So using our step function, we're going to come over here and look at the graph, and we're going to figure out what that value is. Okay, so coming over here on the graph, where 2.6 is, 1, 2.6 come up, and you can see that integer right there is 3. So the answer here is 3. And then a negative 2.3 will go left, 1, 2.3 go down till you hit your graph, and you can see that that answer is going to be negative 2. So you're looking for the greatest integer that goes with that. Now you can evaluate that on your calculator. So if in your graphing calculator you hit math and then you go over to the numbers, so arrow over right to numbers, and then go down to number 5, that's the greatest integer. So you would just type in int parenthesis 2.6, close your parenthesis, and then it will give you the answer of 3 and negative 2. So you can see that, I'll put those there so you can see a little better. 3 and negative 2. It will also, so you can do it without a graph. You can use your calculator to help you figure that out. Okay, so this one says take your greatest integer step function and you're going to multiply it by 2. So remember, a 2 out in front, that's your a value, and that's going to stretch your graph vertically by 2. So normally, we start right here, an open circle, and then I'd go up 1 and do the same thing. But since I've got a 2 out in front, I'm going to go up 2, and then open circle, up 2, open circle, up 2, open circle, go the other direction, down to open circle. Okay, and then same thing here, we can evaluate 1.5. So we come over here 1.5 and my answer is 2. And we'll do the same thing for 2. So we'll go over here 1, 2. Notice you have an open circle there. So you're going to have, right here is an open circle. So I'm going to have to keep going up until I see the closed circle. So that's going to be 4. So our answer is 4. All right. So that's kind of how the step function works. This one right here, now we're going to talk a little bit about piecewise functions. So piecewise functions are just parts of a graph. So this one has two parts. It has the top equation, which is a parabola, the bottom equation, which is a square root. We're going to graph those two on the same graph and then see what it looks like, keeping in mind our boundaries. So what are our boundaries? You need to look over here on the right. This is your boundary notation. So right here it says x is less than or equal to 2 and x is greater than 2. I know that 2 is a boundary line, so I'm going to come over here and put a dotted line at 2. Okay, next thing I'm going to do is I'm going to graph this top equation, this parabola, x minus 1 quantity squared plus 4. So the vertex of that parabola is over 1, up 4. And then I'm going to graph that parabola. So I'm going to go up 1, over 1, up 3, 1, 2, 3, over 1. I'm not going to go up 3 and over 1 to the right and put that point there on the right because that is in the wrong boundary. The boundary with this equation says that x is supposed to be less than or equal to 2. So I'm only supposed to draw my equation on the left-hand side of that boundary. And on the boundary line, it is a closed circle because this is equal to. So I'll just sketch that parabola, draw that in. Okay, now I'll do the other side. This one is the square root of x minus 2 plus 3. So the starting point on that is 2, 3. So go over 2, up 3. And then graph my square root function. So up 1 over 1, up 1 over 3, up 1 over 5. And then I'll sketch that in. Let's take a quick look right here at the boundary. Notice that it is not underlined right here. So that means it is an open circle on the boundary line. Right here is an open circle. And that's what that piecewise graph would look like. We've got two partial graphs, one on the left side of 2 and one on the right side of 2. Okay, this piecewise looks like it has 3 graphs. So I'm going to have to go ahead and put those boundary lines in. So I do a quick look over here on the right, see what I'm working with. It looks like I've got 2s, 4s, and 9s. I'm going to put a boundary line at 2, and then another one at 4, and then another one at 9. Okay, so let's start with this graph here on the top right here. This x squared, a negative x squared plus 7. So that's a parabola. Its vertex is 0, 7. So I'm going to come up to 0, 7. 1, 2, 3, 4, 5, 6, 7. It's negative, so it's going to graph down. So I'm going to go down 1 over 1, down 3 over 1, down 5, 1, 2, 3, 4, 5 over 1. And then I'm not going to do 1, 2, 3, 4, 5 over 1. I'm not going to do that point because that's in the wrong boundary area. Okay. So let's go ahead and draw that graph. So here's my part of my parabola that I need to draw, that piece right there. Let's double check. In our boundary, I see that it's underlined, so that means on my boundary line, this should be a closed circle right here. Okay, the next one is y equals 3, so that one's a constant. So a constant is just the horizontal line up at 3. So I'm going to start here at 3, but I'm not going to graph right here on that left-hand side because that's not part of my boundary. So I'm going to put, let me finish that. So I'm only going to go from the right-hand side here. I'm going to go in between my two boundary lines. So at 3, I'm going to draw a line right here like this. I'm going to check my boundaries. So at 2, it's an open circle, and at 4, it's underlined, so it's a closed circle right here. Open circle on this side, but since it was already closed, it just stays closed. If you have an open and a closed circle overlapping, it's closed. Okay, and then the next one is a line. This one right here is a line that has a y-intercept of -3 and a slope of 1. Well, if I come down here at -3 and a slope of 1, and I start to count that out, I'm going to go through 2 areas that I'm not going to need my points. I don't need my point until I get on the boundary line of 4. So here at 4 is my first point. It's an open circle. And then I'm going to go up 1, over 1, till I get to my boundary line on 9, and that's a closed circle. And then I'll just sketch that in, and that's my piecewise function right there. Okay, so piecewise functions, you're just going to take parts of graphs, graph them with their um, boundary lines, graph the graph within the boundary lines. Okay, this one, write the linear function, has the given values. So basically, this is something we did clear back at the beginning of Unit 1. We did this on the very first day even. This function notation means when x is 1, y is 3. So basically, you have the point 1, 3. Over here on the right, f of 4 equals 0. F of 4 equals 0 is basically the point 4, 0. So if I'm going to write an equation for that line, I need a slope. So I'll start with my slope formula. So 3 subtract 0 over 1 subtract 4 ends up with 3 over -3. So my slope is -1. And then I'm going to pick a point, and I'm just going to do my HK value for that point and write my equation. So y equals, my slope is -1. X minus 1 plus 3 is an okay answer. Or if I picked the other point, I could say -1 x minus 4, like that. And that's an okay answer. You could multiply this out. Might be easier to multiply it out. So if you multiplied it out, you'd end up with y equals a -x plus 4. So I guess that's an okay answer also. All 3 of those would be equations of the line that go through those 2 points. So over here on the right, f of 0 equals -2. So basically that equation is saying you have the point 0, -2. F of -6 equals 3 is basically saying you have the point -6, 3. Find your slope. So -2 subtract 3 over 0 subtract -6 ends up being -5 over 6. So if I want to write an equation of a line that has those 2 points, I would take my slope, and then I would pick one of the points. So x minus 0 subtract 2. X minus 0, we really wouldn't write it that way. So we would say 5/6 x minus 2. That's our y-intercept. So that one would be okay. Or we could say y equals, oops, I forgot my negative sign. Those are both negatives. -5/6 x plus 6 plus 3. And you could write it like that, and that would be okay. So those would be okay equations for the line that goes through those 2 points. Okay, so that's pretty much it for the notes for that one. A couple of different ideas. So basically, we were writing equations of lines again, given 2 points. That was this slide here. These middle slides were about piecewise functions. So you're going to have some piecewise functions. These slides were about the step function in particular, the greatest integer function. So you're going to have some questions about the greatest integer function, which is a new function for most of you. You haven't studied that before. And then back at the beginning, just what do we know about our parent functions? Questions about our parent functions. So there you go. You've got, that's it for 1.6. There's our questions. You can do those out of your book.